In this video, I will show you how to set up an autonomous flying vehicle simulation on your personal computer. To simulate and test our algorithm, we need these software setups. First, we install Python 3, PyCharm IDE, Anaconda, and Git software. Then, we create a Conda environment for drone simulation. The last step is downloading the simulator. Finally, we execute a simple Python script to take off the drone, hover for 10 seconds, and then land. The very first step is installing the Python software. You need to install the latest Python 3 version for your operating system. I am downloading Python 3.10.1 for Windows. Launching the installer, adding Python to the path environment variable. Then, install it in the default location. Second, we need to install PyCharm IDE. I am downloading the PyCharm Community Edition, which is free. Then, launch the installer and install it in the default location. Now, I am creating a new project in PyCharm and setting the default Python 3 as interpreter. In the default main.py file, I am writing code to print "Hi, welcome to Python programming." Here, we can see the output message. So, I have installed PyCharm and is working as expected. The third step is installing Anaconda. I am downloading the Anaconda Individual Edition. It may take a few minutes to complete the download. After completing the download, now, I am launching the installer and installing it in the default location. The fourth step is to install the Git version control software. I am downloading the Windows version of the Git and installing it in the default location. Now, the fifth step is to set up the Python libraries to interface with the drone simulator. I am opening the GitHub repository. github.com/obid-auto/pydrone. Then, copying the repository URL. Then, launching the Anaconda PowerShell prompt. I am moving into the Documents folder. We can view the available environments by executing the command conda env list. By default, we have only one environment, base. Now, I am downloading the GitHub repository by executing git clone command. We can paste the URL by pressing the right mouse button. After downloading the repository, I am moving into the folder. You can list the files by executing dir command. Now, I am creating a new conda environment by using pydrone.yml file. To create a new conda environment, I am executing the command conda env create-f pydrone.yml. It will take a few minutes to complete the installation. Make sure you have good internet connectivity. If it is not completing, even after 15 minutes, you can hit Enter key in the terminal window or close and try again. After completing the installation successfully, we can view the newly created environment by executing the command conda env list. The sixth step is downloading the simulator. I am opening the GitHub repository, github.com/obid-auto/pydrone. Then, open the simulator download link. Download the appropriate file for your operating system. Now, I am unzipping the file and launching the executable file. After launching the simulator, I am selecting the Backyard Flyer module. Now we can visualize the simulator environment. The final step is to run a simple script to operate the drone autonomously. In the downloaded GitHub repository, we have an example script to take off and land the drone autonomously. I am running this script by executing the command python, followed by takeoff and land.py. Now we can see the action in the simulator window. The drone takes off automatically, then hovers for 10 seconds, and then automatically lands. Now we will see how to execute the program in the PyCharm IDE. PyCharm IDE is easy to edit and debug Python programs. I am opening the PyCharm IDE. Then, open the GitHub repository folder. This is the Python program we executed earlier to take off and land the drone. Initially, PyCharm takes a few minutes to index all the new library files. We have to wait until it completes the indexing operation. Then, we have to ensure that the Python 3, the interpreter is selected from PyDrone, Conda, environment. If the PyDrone environment is not selected, then, we have to add the interpreter manually using the Add Interpreter menu. Now, I have selected a Python interpreter from PyDrone environment. Then, make sure the simulator is running. Then, in the PyCharm IDE, right-click on the program and choose Run Takeoff and Land. Then, switch to the simulator to see how the drone moves for your control code. This is the program to take off and lands the drone automatically. First, I am importing the drone and MAV, link, connection classes from the library. Then, import the time package for using the sleep function. I am creating a MAV link connection object to communicate with the drone simulator. Then, create a drone object using the existing MAV link connection. I am establishing the connection with the simulated drone by calling the start function of the drone object. I am waiting for 5 seconds to ensure that the connection is established. It is very important to introduce this delay at this point. Then, I execute the function take control to operate the drone in autonomous mode. The arm function is then executed to turn on the rotors. Then, execute takeoff of 3 to take off the drone to the height of 3 meters. Then, I am hovering at the same height for over 10 seconds. Then, execute the function land to move the drone to the ground level. Then, execute disarm function to turn off all the rotors. Then, call the function release control to change the drone operating mode to manual. Then, close the connection with the simulator drone by calling the stop function of the drone object. You can develop your own algorithms to perform the various operations and evaluate them in the simulated environment before the implementation. Thank you for watching the video.